Hi guys, so this video is specifically made for my online learners. So remember guys, previously we were looking at current electricity, and so I want us to answer this question together so that we just get to remind ourselves on one or two things. So of course feel free to pause the video and attempt the question. So we are saying figure 8.1 shows an electric circuit diagram. So we have this. Question A says calculate the resistance between AC. So point A is there, point C is there. So how do we get the effective the resistance between A and C? How do we get the resistance? So between A and C we've got how many resistors? 3. 1 and these two that are in parallel with each other. So how do we get the total? So first things first, we are going to deal with these two that are in parallel. We will deal with these two, and then now look at this. When we deal with those two, look, we have 3.6. We have 3.6 ohms there. We have 3.6 ohms there. So when we find the total of these two, you are just going to have something like one resistor there. Okay, you're going to have something like that. So to now get the total resistance in this whole circuit, we're just going to add this one and the total of these two, which will be this one. As you can see, they are going to be in series with each other. So the total of these two resistors will be in series with this one, and so to get the final answer, we are just going to add them. So question A, I'm saying that we deal with these two first. Now these two resistors are in parallel. How do we get the total resistance? So we are going to say resistance equals, because they are in parallel, we're going to say R1 times R2 over R1 plus R2, like that. So the resistance will be equal to R1 is 4 multiplied by R2, 6 over 4 plus 6. So from there we multiply, we say 4 times 6 will get 24. So the resistance will be equal to 24 divided by 10. When you say 6 plus 4 plus 6, you get 10. So when we do the divisions here, the resistance will be equal to 2.4 ohms. Now this is not the final answer. So it means these two guys have got a total of 2.4. So it's more like we have got 2.4 here. We have got 2.4 ohms. So to now get the final answer, we just add these two guys. So we are going to say the total resistance now, R3 will be equal to R1 plus R2. So the total resistance will be equal to R1 3.6 plus R2 2.4 ohms. So the total resistance will be equal to when we add these two on our calculator, we should get 6 ohms. So 6 ohms is going to be the total resistance, or the resistance between AC. So this is going to be the final answer. Question B says calculate the potential difference across the 6 ohms resistor. So across the 6 ohms resistor here, what is the voltage? What is the voltage? So I want you to understand that to get the resistance that is across this 6 ohms resistor, to get the voltage that is across this 6 ohms resistor, we will first need to find the voltage there. Okay? We will have to find the voltage there, and then after we find the voltage there, we subtract from the total voltage. It will give us the voltage across the 6 ohms now. So what is the voltage here first? What is the voltage across the 3.6 ohms? So what formula are we going to use to find the voltage across this 3.6 ohms resistor? We are going to use this formula where we're going to say resistance equals voltage over current, like that. So the resistance here is 3.6. So 3.6, okay? 3.6 equals, the voltage here is what we are looking for, over Do we have the current here? No, we do not have the current. So we need to find the current again, okay? We need to find the current. So how do we get the current flowing through this 3.6 ohms resistor? We are still going to use Ohm's law. We're still going to say resistance equals voltage over current. Now look at this. Do we have the total resistance in this circuit? Yes, we have. It is 6 ohms. So where there is resistance, we put 6 equals. Do we have the total voltage? It is 24. So the total voltage is 24 over the total current that we are looking for. And then we do what? Cross multiply. So 6 times current, we get 6 current equals 24. And then from there, we are going to divide both sides by 6 like that. So the current will be equal to 4 amps. So the current flowing through, because remember current flows from positive to negative terminal in that direction. So the current flowing here is 4 amps, right? It is 4 amps. So how do we get the voltage here? We say resistance equals voltage over current. The resistance here is 3.6. We've put that 3.6 there. The voltage is what we are looking for. So the current flowing there is 4. So we say over 4, and then from there we cross multiply. So 1 times voltage, we get voltage equals, so on our calculator when we say 3.6 times 4, the answer gives us 14.4. So the voltage across that is 14.4 volts. But this is not the final answer. Remember, the question says calculate the voltage or the potential difference across the 6 ohms resistor. So now to get the voltage across the 6 ohms resistor, we are just going to say voltage is equal to, what is the total voltage? It is 24. So we shall say 24 volts minus the voltage here was 14.4 volts. So the voltage will be equal to, so when you say 24 minus 14.4, you are getting 9.6 volts. So 9.6 volts will be the voltage across the 6 ohms resistor. So if there's 9.6 volts here, because they are in parallel with each other, across the 4 ohms resistor there is also 9.6 volts. Now the question is, why are we doing this? Why are we subtracting from the main value there? Look at this. If you have 2 resistors in series, okay? If you have 2 resistors in series, let's say for example, you have something like this. You have resistor 1 there. You also have resistor 2. So I'm calling this R1. This is resistor 2. So if you have these 2 resistors, let's say for example, the total voltage in this circuit is 10 volts. If the voltage across this R1, if the voltage across R1 is, say for example, 4 volts, what is the voltage across R2? We subtract. We say 10 volts minus 4 volts, we get 6 volts. That is what happens in a series connection. Voltage is not the same. It is not the same. But the sum total of the voltages across the components should give us the mother figure there. So similarly, this guy is in series with this one. In this case, we were ignoring this. Okay, we ignored that when they asked for the resistance across the 6 ohms resistor. When they asked for the voltage across the 6 ohms resistor, we ignored that guy. So what did we do? We first had to find the voltage here, just like in our case here. To find the voltage there, we need the voltage there, so we have the voltage there, okay? And then we subtract from the main value, which is 10, to give us 6. So similarly here, we needed the voltage there, and then we subtract from the value there, the main value. The answer we get is the voltage there. It is also the voltage across the 4 ohms resistor. Alright guys, see you in the next video. Otherwise, that is how you get that 4 marks.